On question number 3, we are trying to maximize 2x plus 3y. And these are our constraints. So our first step is going to be to graph all of these to find our feasible region. So before we graph them, we need to isolate for y. So on the first one, I need to subtract x from both sides. On the second one, the same thing. I need to subtract x from both sides. And then on the third one, I need to subtract x and then divide everything by 3. And then lastly, we have y is greater than or equal to 0. So I'm ready to graph these on the calculator. So if I go to the y equals menu, I want to type in negative x plus 3, negative x plus 9, negative 1/3 x plus 2, and 0. So these are my 4 lines. And then if you go to the window, we're going to use the negative 2 to 12 and negative 2 to 12 for the x-min, x-max, y-min, and y-max. So then press graph, and this is what our graph looks like. Now I'm ready to generate the shading, and I like to do the reverse on these because I think it's easier to see. So this was y is greater than or equal to negative x plus 3, but to do the reverse, I'm going to do the bottom shading. With negative x plus 9, it was less than, so I'm going to do the upper shading. For negative 1/3 x plus 2, it was greater than, so to do the reverse, I'm going to do the lower shading. And then y is greater than or equal to 0. To do the reverse, I'm doing the lower shading. So then if we press graph, this is what our shading looks like. So our feasible region is this region right here. So we have to manually cut off this part right here because x has to be greater than or equal to 0. So it has to be to the right of the y-axis. So that is my shaded region. So we still need to find the corner points, so we still need to use the intersection command. And it's easier to use the intersection command if we don't have the shading on the calculator. So if we go back to the y equals and change these all back to the line symbol and then press graph, we can get rid of our shading. Now before we find the intersection points, I want to draw the graph on my paper. So it's going to look something like this. And my feasible region was right here. So I want to find this corner point, this corner point, this one, and those two. So I actually have 5 corner points that I need to find. So I want to use the intersection command on the calculator to find the corner points. So if we press second calc or second trace, then we get to the calc menu and we want to select number 5, which is the intersection command. So let's try to find this corner point first. So I need to select this line as well as this line. And right now my cursor is on this line. Also at the very top it tells you which line it's on. And again, pressing left and right navigates the current line that you're on, and using the up and down arrows changes which line you're on. So this is okay. I'm going to press enter. So it's locked in this as my first line, and I want to select this as my second line, but my cursor is on this line, so that's not what I want. So I need to press down, and now it's on this line. So again, I already have this selected as my first line, and now the y3 equation is what I want to use for my second line, because I'm trying to find that intersection point. So if we press enter, now it has both of these selected, and we can make a guess and press enter, and we get the intersection point, which is 1.5 and 1.5. I want to find the next corner point, so I need to use the intersection command again. And let's find this corner point here. So I need to select this line and this line as my two lines. So the cursor is on y3, so make sure that your cursor is on y3 and press enter. So I have this line locked in, and then I need to lock in this line, the axis, and that would be y4. So make sure that you press up or down with the arrow keys until your cursor is on y4, which is the axis, and then press enter. So it has these both locked in, and then you can make a guess and then press enter, and then it finds the intersection point, which is 6, 0. To find my next corner point, I need to use the intersection command again. So I'm trying to find this corner point here. So I need to select this line as well as this line. So make sure that your cursor is on y2, this line, and then press enter. And then my second curve needs to be this line, the axis, which we have as y4 in our y equals. So right now my cursor is on y3, so I need to press down, and now it's on y4. So I need to press enter. So I have this line locked in as my first curve, this line locked in as my second curve, and then I can make a guess and press enter, and then it gives me the intersection point, which is 9, 0. Our last two corner points are on the y-axis. So we can find these using the value command. So if you press second calc, number 1 is the value command. And this will take you to the graph, and it will give you x is equal to, and you can type in a value for x. So we want to know when x is equal to 0, and then press enter, and then the cursor will show up on the y-axis, and if you press up or down, it will scroll through all of the different corner points that are on the y-axis. So we have 0, 3, 0, 9, 0, 2, 0, 0. So the ones that are on our feasible region are 0, 9 and 0, 3. Now that we've found all of our corner points, we can label them on our graph. So this was 0, 9, 9, 0, 6, 0, 1.5, 1.5, and then 0, 3. So these 5 corner points are going to be our 5 candidates for the maximum value. So we need to plug these into the objective function. So 2 times 0 plus 3 times 3, this is 9. 2 times 0 plus 3 times 9 is 27. 2 times 9 plus 3 times 0 is 18. 2 times 6 plus 3 times 0 is 12. And then 2 times 1.5 plus 3 times 1.5 is 7.5. So the maximum value is 27. That is our largest value here. So our final answer is the max is 27, and this happens at 0, 9.